Welcome to the uvwasi meeting for November 29th, 2023. We are going to do our standard thing of looking at things that were tagged for the agenda. Really, the main thing we have this week is, guys, regular update on progress on Preview 2. So I'll let you take that away.
Hey, it's been a while since our last meeting, but the last thing we kind of discussed, I think, was that the Jcur project, which is a project I'm working on for Preview 2 support, we are now targeting a comprehensive implementation of Preview 2 on top of node.js as an implementation of Preview 2. So we're sort of one of the implementers implementing Preview 2 and getting to full conformance against the current Preview 2 specifications. So that's the focus of the project currently. And if it's useful, I can actually share my slides that I presented at the WASM CG meeting. The WASI meeting about the project. Let me just share my screen here.
Yeah, it sounds good.
Right. So this is a little bit out of date now, and I'll just kind of go through it fairly quickly. But it's good to kind of just follow the sort of rough overview of the project and status. As I say, the status hasn't been updated for where it is at the moment. So the Jcur project is sorry, that's actually a typo. It's npm install g at bytecode alliance /Jcur. And it's an npm package that's native JavaScript and gives you the ability to run WebAssembly components through transpilation into JavaScript and core WebAssembly. And the new thing that we've been working on recently is full support for WASI Preview 2 inside of Jcur, which is being implemented as a library on npm called bytecode alliance Preview 2 shim. And we've been collaborating with Microsoft on this at the moment. So it's myself, Joshua Waits, and Wasim Shegem. And the overall Preview 2 integration, the goal for our project is to prove out what it might look like if we can update uvwasi and at least the Node core WASI implementation to Preview 2 and how that can work in Node. Initially, our implementation is it's entirely building on top of Node core libraries. So it's a very, very high level implementation. It won't be performance optimized, but it'll be correct. And that's the most important feature of the implementation. The benefit of that is that if we support all Node.js libraries, if we support it being built on top of Node.js core libraries, that it should be able to work anywhere you can run Node.js without too much of a platform limitation. And in theory, that should extend to platforms like Bun and Deno as well, because they often polyfill the Node.js core libraries. There's going to be a couple of top-level commands for Jcur. There's this Jcur run where you can run an actual binary, and it'll support all of the system bindings, and it'll run it to completion. And then we have Jcur serve as well, which supports the HTTP proxy world. So in this HTTP proxy, you can write a server handler fully in WASM, and it'll work. And when you're running these Jcur runs and Jcur serves, it's a JavaScript implementation, so it's fully virtualizing. You're basically implementing like component model on top of it's like almost like implementing POSIX on top of Node on top of POSIX. It's like a double virtualization. But I'll at the end of this, I'll go through the low-level bind gen plans if that's useful. And so it's full support. We won't have performance from the start, but we will have comprehensive implementation experience, which is kind of the main goal. It's kind of an exercise in getting as much feedback into the process as possible, and then hopefully we can come around again and do a core integration that's optimized.
The last line is the one that's particularly interesting to me, is that there'll be like a full test suite that validates the implementation. which is
Yes,
good.
yeah. So that's very much what our work at the moment is. It's correctness and spec feedback and conformance. And we've now at the time that I presented this, which was only 3 or 4 weeks ago, we had as you'll see in the list that I'm going through, we had very patchy performance across the various subsystems. So this is for the IO, which is streams and polls, low-level streams interface. They're comprehensive streaming interface with high watermarks, flushing, back pressure, etc. So it's a really sort of fairly comprehensive streaming support. CLI, which is environment variables, standard IO, exit, and top-level commands. The HTTP, which is both the proxy handler and the ability to create HTTP requests. And so you can see from these check marks that we were fairly unfinished. Sockets, there's a raw sockets interface, and clocks as well, and clocks and random file system. And
How do you
yeah,
run
that's
that
all I've got
test?
on the slides actually.
How do
Uh,
you run the test suite? Is it like,
yeah,
just is it like, is there a JavaScript
it's the test programs in WASM time are written as REST applications, which have certain assertions, and so we build those REST applications into components, and then we test those components on Jco as the runner host. So that Jco run command, which then runs those components on top of Node.js through JavaScript and core WASM, and then binding to the Node.js standard library to do the basically all the way down to the POSIX primitives.
Okay, but that would be reusable for a native
Right. So you in most cases where you'd use Jco run, you would probably want to just use WASM time run. But there are some benefits in that, V8 has a very powerful WebAssembly engine, a very fast compile time, and it's not as terrible as it sounds. But having that support for comprehensive preview 2 in Node.js means that any component written against WASI, which is typically most components because you want to use systems bindings, will work in any Node.js environment using this project. And by having that full conformance against the test suite, we'll be able to support that. And then when we do the lowering down to really optimized bindings, we can sort of selectively use the more polyfill kind of approach, which is this rapid approach, or we can use the actual low-level bind gen if and when we can support that. So the conformance tests, there's 99 test cases, and at the time that I presented that, I think we were at something like 30 passing, and I'm now up to just over 70 out of 99. So we should have full conformance by the end of next month. And so Preview 2's completion timeline is pretty much end of this year, early next year at the moment. And there's been some implementation feedback on some of the HTTP interfaces, things like that, but it's mostly fairly complete at this point, and it's mostly in a feature freeze as well. Yeah, that's the update on Preview 2 work, which has been already coming along at this point. And then I can go briefly into the low-level bind gen structuring, unless maybe it's a separate thing. We can kind of, if there's any questions or discussion you want to have on that, we can also do that.
Sounds interesting. Yeah, I don't have any other questions on this part. Oscar, how about you?
I had something to tag on, but it sounds related to what Guy's about to say. So I'll just wait a moment.
We can use it as a segue then, so feel free to.
Yeah, I was just going to say, speaking of the low-level bindings, tomorrow is the first vote to advance a handful of the Preview 2 specifications to Phase 3. And so if that vote passes tomorrow, that's the mark of we're actually supposed to start implementing all this stuff in Node. And so we can maybe, like, depending on what happens tomorrow, at our next meeting this upcoming week, we can discuss trying to put some plans in place to actually get this work done.
Yeah, and I'm going to be presenting on this implementation at that meeting tomorrow, and sharing some of our implementation feedback as well. So yeah, we should have an update on that for the next meeting for uvwasi. I don't know if how the timing is going to work out on that meeting yet. I guess it's getting late in the year, but certainly things are moving at the moment.
Mhm.
Yeah, on the low level bind-gen side, the main thing is sort of, if you want performance optimized bindings, you want, I guess the analogy to use is WebAssembly itself on the web. So when you have a WebAssembly module, it can import functions from the JavaScript host, and you provide those functions directly on this kind of object that you feed in when you instantiate the WebAssembly module. And if you pass in a function that is a native function or another core WebAssembly function, you're not going to run it the same way you run any old JavaScript function. When WebAssembly compiles, it's going to compile that function to be a direct fast call to the function that you passed in. And so I think the same kind of concept of a fast call protocol would make sense for component model WASI imports. So when you import something, you would import a function that effectively, the high level function is the thing that exists in JavaScript. So as a JavaScript user, you have a handle to this function and you can call it. And when you call it at the high level with the high level types. So you're passing, real objects to it. You're getting real errors. You're getting real, real high level behaviors for this function. But when you pass that function into a component that understands the low level bind-gen protocol, it should be able to see from that function that there is actually another low level version of the function that is optimized to work at a binary level. And at a memory level and a pointer level, etc., so that you would directly call into that function instead. And that would be the kind of native function that you would want to be implemented in C++, and then linked into your Node.js application. That would be the very fast version. So that way you don't have to trampoline through JS, which is normally what we call lifting and lowering, where you lift the low-level types into high-level JS objects, and then lower them again when you make the call. Instead, we can skip the entire JS trampolining. But the important point is that the high-level representation does exist, in that as a JavaScript developer, I can still import these WASI functions and use them as high-level functions, even though they still have low-level counterparts. And the low-level one is typically the one you always want for performance, but you create the illusion of it being like a single function that kind of has this existence, and it's analogous. So I think the initial implementation path might be something like that, where even in the Preview 2 Shim project, we could potentially stamp all of the high-level functions with a kind of a pointer to their low-level protocol functions. And then how that gets implemented sort of depends on how we're going to integrate with either uvwasi or some kind of native binding in Node.js. And that's a whole area to be figured out and planned. But I just wanted to share the thoughts there on how that ideally would come together. And yeah, it's something that we could already start planning and putting some thought to now. There's no reason that we couldn't. Personally, I'm putting all my resources into getting full conformance on implementation right now for this high-level bind-gen. But moving to the low-level bind-gen will, of course, be the performance target. So, yeah, that's kind of the way I see it at the moment. And yeah, any thoughts or feedback on that process would be very welcome.
Is there anything in WASM itself that helps with that sort of invocation style of, or is it something the runtime needs to build on top of to provide that?
Yeah, so it would be basically just the core ABI. So the component model defines a kind of a core ABI that is the core WebAssembly, the non-component WebAssembly signatures for the functions. And it would be basically that with a little bit of extra metadata for like memory indexing and alloc function indexing. It would just be like 2 or 3 extra numbers on top of the current core ABI, which are currently core ABI attributes. And that combination of a core ABI plus the kind of indices that you're pointing to, it would be the sort of protocol that you would use as core functions, and then it would just be standard kind of low-level linkage semantics at that point.
Right, because I think today, I'm just trying to think how like the current, you know, the exports, like we might generate some exports that are available, but it's the existing V8 WASI implementation that manages calling those exports, I think. Is that right? Like,
you mean WASM implementation, or?
well, like, you know, so for example, yeah, like we've provided a bunch of functions which we expose as JavaScript functions. Those, I guess, we have like a wrapper, like our kind of standard wrappers to when you call JavaScript, it ends up calling C. But you're
Yeah, so it'd be something like a symbol on that function, which
right,
would be
okay.
like the sort of low level pointer to the core function that would then be this WebAssembly core function or a native function. Yeah.
Right. I was just trying to understand. It's like, is it that the WASM implementation knows how to do that? Like, because today we kind of just say here's something that looks like JavaScript and it knows to do the right
that
thing.
integration is an interesting point. Yeah. Perhaps we may need like a WASI dot instantiate function where you could pass it a component and it would then make sure it's wired up correctly or something like that. We do need to think about what the shape of that integration looks like a little bit. Yeah.
Because I think like in Node add-on API, we've added like hidden symbols and stuff like that. So that's probably not so hard. I'm just wondering how the thing that uses the symbols.
Exactly. Yeah. I at least without V8 having component support, we would need some kind of instantiation wrapper, I think. So something like a WASI.instantiate might be the way to do that.
And then
that could potentially be done as a sort of an extension of our current. So instead of, you know, at the moment where you use WebAssembly.instantiate and then you pass the import object, it would effectively just be a wrapper for that one liner where it's like, instead of passing your module into WebAssembly.instantiate and taking the import object from WASI, you could pass the component into WASI.instantiate and it would automatically give it the import object. So some kind of inversion like that.
Okay.
But yeah, I don't know if we should start throwing around designs or not for that kind of thing. It's difficult because we're not quite at an implementation point, but I think if there are people interested in working on implementations, the designs are there. So certainly it's worth noting that there's no reason that we couldn't be prototyping. It's just a question of if someone's interested in working on it.
Okay, good to know. Any other topics on that front that we should chat about today?
Yeah, that's all the update I have on Preview 2. Yeah, if there's nothing else, we can always end the meeting earlier, and happy to give another update next time.
Okay.
Yeah.
Okay, well, thanks for your time, and thanks to everybody who came. We'll see you all next week.